Good morning, students. As you can see, today's topic of discussion would be IPv6 header format. In the last few lectures, we have discussed about what is IPv6, what are the features of IPv6 protocol, and the comparison between IPv4 and IPv6 protocol. This lecture of mine would be dedicated towards another important topic, that is the header. How can we see it is different from IPv4 header, which we have already discussed in detail. We start with it. An IPv6 address is 4 times larger than IPv4. But surprisingly, the header of IPv6 address is only 2 times larger than IPv4. The IPv6 headers have one fixed header and 0 or more optional extension headers. This is a unique feature of IPv6 protocol, which was not there in IPv4. IPv4 में children जो options and padding वाला layer था in the header format, that was fixed, that was attached to my IPv4 header. Optional वो layer थी, मगर वो header was always there. ठीक है? It was a part of a single layer. IPv6 में we find that there are two kinds of headers. One is the fixed header and the other one is the extension header. Okay, this extension header lies between the fixed header of IPv6 and the TCP header of the segment that propagates from the transport layer to the network layer. All the necessary information that is essential for a router to keep is kept in the fixed header. जो essential part of information required for routing process होता है, that becomes a part of my fixed header. The extension header contains the optional information that helps the router to understand how to handle a packet flow. To have an elaborate understanding, I've given you this figure, all you can see on your screens. Below is the IPv6 fixed header format according to RFC 2460. This RFC 2460 is needed to be remembered for objectives. Okay, which RFC talks about IPv6 fixed header 2460? You have to remember that. Okay, now coming on to this header format, you can see this figure I have tried to showcase that it is of 4 bytes. Each layer, this is a similarity of IPv4 and v6 header format, that each layer comprises of 4 bytes of size. Okay, octet 1, octet 2, octet 3, octet 4 means there are total 32 bits. 0 se leke 31 tak counting I have shown you. Now, the first layer over here is of version, which is of 4 bits, traffic class, which is of 8 bits, flow label, which is of 20 bits. So first layer had 3 sections, that is version, traffic class and flow label. Second layer is of payload length, 16 bits, first 2 bytes. Then next 2 bytes may, third byte is for next header and fourth byte is for hop limit. How many routers are expected to be crossed over during the routing process? This hop limit is something similar to what we had TTL. If you remember IPv4 में TTL field होती थी, right? Time to live, वो hop count देती थी. उसी तरह यहाँ hop limit है 8 bits की. That is the fourth bit of the second layer, right? और यहाँ पर next header जो field है, इसमें कुछ predefined values आएंगी जो ये signify करेंगी कि क्या इस fixed header के बाद कोई extension header है, अगर है तो किस type का है, और अगर नहीं है तो TCP header है क्या? All that information. For all that, there is a constant values assigned to it, a table of which will be given to you in the forthcoming lecture. ये हो गए first 2 layers की बात. तो 4 byte 8 byte हो गए total. Coming on to the third layer, which is of source address, and the fourth layer, which is of destination address. Now, if you see here, source address is of how many bytes? 16 bytes. 16 heads are 128. Okay, तो 128 bits मतलब 16, right? और ये source address होता है मतलब 4 4 8 4 12 4 16 4 लेयर बना के एक लेयर बराबर होता है source address, क्योंकि IPv6 का header ही 128 bits का है, right? और ये 16 bytes का destination address. अब 16 plus 16 32 bytes तो यही हो गए. 32 bytes में फिर ये 4 और 4 8 बाइट्स, तो टोटल हेडर लिमिट क्या है 40 बाइट्स। तो ये मैंने आपको दिया हुआ है। IPv6 हेडर जो फिक्स्ड हेडर है उसका साइज कितना होता है 40 बाइट्स। First two layers of 8 bytes, 4 and 4 each, and next two layers of 16 and 16 each. Okay, for source and destination IP addresses of IPv6 format. In the table given here, I have tried to explain you the significance of each. Version 4 bits का, इसमें obviously version field वहाँ पे भी थी IPv4 में. It represents the version of the protocol 010. 0110 is what? Okay, 6. 100 is 4, 101 is 5, 110 bits में is what? 6. 6 means IPv6 version protocol. वहाँ पे 100 होती है version की value in IPv4, that is 4. 4 का binary conversion. Coming on to the next part of the first layer, traffic class. These 8 bits are divided into 2 parts. The most significant 6 bits are used for type of service. ये था IPv4 में, to let the router know what services should be provided to this packet, and the least significant 2 bits. Least significant left side के, most significant right side के bits. आपको पता होगा ये. Okay, the least significant bits are used for explicit congestion notification. कि अगर कोई कंजेशन है तो उसके बारे में कोई इंफॉर्मेशन. Okay, talking about the next part, that is flow label, which is of 20 bits. This label is used to maintain the sequential flow of packets belonging to communication. The source labels the sequence to help the router to identify that a particular packet belongs to a specific flow of information. Sequential flow control mechanism में use होता है reordering avoid करने के लिए, streamlining. फिर payload length, total length field होती थी अगर आपको याद हो उसकी ही तरह. This field is used to tell the router how much information the packet contains in its payload. Payload is composed of extension header and upper layer data with its 16 bits up to 65,535 bytes. This can be indicated, but if extension headers contain hop by hop extension header, then the payload may exceed 65,535 bytes in this field. Next header, as I told you, this field is used to indicate either the type of extension header, or if the extension header is not present in that, then it indicates the upper layer PDU. Okay, so this is about next header utilization. Source address, 128 bits. This field indicates the address of the originator of the packet, and that destination address provides the address of the intended recipient of the packet. Now, talking about the IPv6 extension header, I think for this lecture, this much is enough, because IPv6 ka extension header wala part, I would like to discuss in detail with you all in the coming lecture that would be streamlined live for tomorrow's class. That's all for today. Thank you.